G'day everyone, welcome to another episode of Mr. Code STEAM podcast where we talk about science and technology after school. We're coming to you another live lesson today, so if you have any questions and comments, make sure you type it into the live chat, okay? And I will try my best to answer your questions during the lesson. Okay, let's check out who is online. Excellent. G'day fellas, how's it going? Hello ladies and gentlemen, welcome. See the chat is already boiling over with lots of content. That's really great. Okay, so let's get right to it. So last week we had a look at the new LEGO Education BricQ Motion Prime box. We looked at every single project in BricQ Motion Prime. And if you want, you can check out the last video in the description, okay? So I'll add it in the description afterwards. And you'll be able to have a look at the previous video where we looked at all the different projects for BricQ Motion Prime. And today we're going to take a little bit more of a deep dive into one of those projects. And that is this one, the ski slope model, okay? If you like these videos, make sure that you like the video and subscribe, and that way you can get more notifications about the upcoming episodes, okay? So let's have a look at our model. So here you have the ski slope model. I'll put it on this angle so that you can see it a little bit clearly. So the cool thing about this model is that this is the first time that LEGO Education has given us a pneumatic system to work with. So a pneumatic system is identified by these parts here. So we got this blue pneumatic pump. We have this control valve over here, this gray piece, where you can direct airflow to different parts of the system. And then we also have this pneumatic cylinder, this yellow part over here. And what that does is it can expand and contract depending on where you direct the airflow. Okay, it's really, really cool because this is the first time, like I said, that LEGO Education has given us a pneumatic system. You've got these LEGO pneumatic pieces in different like LEGO Technic kits, but this is the first time that we can use it in an educational context, which is really, really fun. Okay. If you have any questions, you can feel free to type it in now. Okay. All right. So now that we can see all the different LEGO parts of a pneumatic system, let's have a look at what a pneumatic system actually is. So a pneumatic system, the word pneuma means air. So a pneumatic system is designed to compress air from the atmosphere into small, tight spaces. And then it forces the air through different parts of the system to do work for us. Okay? So pneumatic systems are really effective because machines that use air to do work has very little wear and tear. Okay, you can see this machine over here has all these tubes that are pumping air throughout the machine to cause different air pressure differences to move the machine around. Okay, pneumatic systems are also very reliable because when air travels from one part of the machine to another part of the machine, it doesn't lose any energy. Okay, there's no friction to stop the air and cause any energy to escape. It's like a direct transmission of pressure from one place to another. And finally, pneumatic machines are really durable because things like valves and tubes and pumps, they're very easy to maintain. And they don't get exposed to as much wear and tear that a gear system or a pulley system or a lever system would normally take. So the energy transmission for a pneumatic system is a lot more efficient, a lot more reliable, and a lot less stressful for machines. Okay. So let's have a look at this pneumatic cylinder in action. I'll switch it back to the table view. All right. So you can see here, I think it's lagging a little bit. So you can see here when I spin this pump, whoops, it's a little bit difficult to see on here. Maybe I'll switch this camera view over here. Okay, here we go. This is better. All right, when I spin the pump, what happens is that it is constantly creating airflow, and it is creating some air pressure differences inside our pneumatic cylinder. And the result is that the pneumatic cylinder is going to expand and extend this this middle part to make the ramp higher. Okay. But when I switch the valve to pump air into the other part of the system, and then I pump air into it again, it decreases the height. It contracts the cylinder. So how does it do that? It's very strange, right? It's like I'm pumping air through one side, it expands, and pump air through another side, and then it contracts. It seems very unintuitive. So let's have a think about, first of all, what the pump is doing. Okay, so when I'm spinning this crank, it is moving the pump in and out. And then in real life, we have these similar pumps for a balloon pump, okay, so, or a bike pump. So here's a example of a balloon pump. And here's a balloon. And then you're going to see that it doesn't matter if I pull the pump or push the pump, it's still making air flow through the nozzle of my pump. So watch this. You see that I pulled it and then air went through, and then I push it and then air went through again. So this is like a one-way pump. So if I keep on pumping, then the balloon will inflate. And it doesn't matter if I'm pulling or pushing on the pump, the air is only going to go out of one direction. Okay, just let it fly away for a bit. So a bike pump or a balloon pump uses the same principle as this this pump that we have in our Lego system. So that's how the air is generated. So that's why when we're spinning the crank, it's creating this constant airflow that is coming out of the nozzle. Okay. So that's one part of the pneumatic system that we can understand now. But how is it that the cylinder expands or contracts? Okay, just because we're pumping air through, wouldn't it just expand indefinitely and then explode, right? Well, it doesn't, because let's have a look at this diagram to see what it looks like. Right, so this is a diagram of the pneumatic cylinder. That's this yellow part of our system. Okay, so when we are pumping air through the red chamber over here on the right-hand side, what happens is that the pressure will build inside the red chamber. And it's a pressure chamber because it is designed to withstand a lot of air. It's designed to take in more air than a normal container would be. Okay, and as it builds up in pressure, the metal part that's dividing the two chambers will get forced over towards the left-hand side. And as that chamber gets forced, gets bigger, and then it forces the metal towards the left-hand side, that's when you get the expansion of your pneumatic cylinder. Okay. When we are directing air through the other chamber, when we're directing air through the blue chamber, then the opposite happens. Okay, so if the blue chamber increases in pressure, then the pneumatic system will force the pin over to the right-hand side. And then what that will do is that will make the pneumatic cylinder contract. Okay? So for a pneumatic cylinder, it's just as powerful pulling or pushing. So that's why it's a really great machine. And as you can see, because there's only air flowing in and out of the machine, there's going to be very little wear and tear in the pneumatic cylinder, as long as you don't get any dust or particles going into the tubes. Because what happens if there are dust particles inside the pneumatic system is that some of the seals won't seal properly, the valves won't seal properly, and air will escape when it's not supposed to escape. So this is a pressure chamber. It's supposed to be very hard for air to escape. But if air escapes for any reason, if there's like particles stuck in between the tubes, then it's not going to work properly. So make sure if you are playing with a pneumatic system on your Lego at home, then make sure that you don't have any dust. Don't play with it outside, for example, and don't put it on the ground, because dust will get into all the tubes and cause it to not work properly. Okay? And here we have a real-world example of a pneumatic engine. So this looks a lot like a steam engine, but this is actually a pneumatic engine because this is a cart that they use to drive coal around underground. This is very olden day technology, but what they did was, because when you're underground, there's a lot of different gases, and if you have a steam engine, then there's a risk that it will explode. But with a pneumatic engine, it's going to be a lot safer, and it's still going to help you do a lot of work. So you see here, the part in front of the wheel is a big pneumatic cylinder. And what it does is it moves back and forth, driving those wheels along the track. So this is kind of like those Minecraft carts, you know, if you play Minecraft and you have those carts traveling around, then you'll know what we're talking about, right? We got a question. What if the thing is made out of iron and oxygen pumped into it? Will it rust? That's a good point. So if inside this pneumatic pump, you'll find that it's actually very slimy. You'll feel that it's there's actually a coat of oil on the inside of the cylinder. So when you touch it, I'm not supposed to touch it, by the way. Don't actually touch it. But if you did actually touch it, you'll feel that there's a bit of oil. And what the grease and what the oil does is it lubricates the system, but it also prevents corrosion from happening inside the system. So the metals usually used inside a piston are selected as like stainless steel or any kind of metal that does not corrode as easily. But in addition to having the right material, we also need to make sure that it is lubricated and protected from the inside as well. But that's a really good question, very good. And the pneumatic system that we have in Lego has all sorts of grease inside to stop air from causing corrosion. And then here we have an example of some construction equipment. But usually for heavy construction machines like this one, we don't use pneumatics. We use something called hydraulics. Okay? Can somebody tell us what you think the difference is between a pneumatic system and a hydraulic system? The clue is in the name, pneumatics and hydraulics. Maybe someone can type in chat. So the difference between a pneumatic system, because pneuma means air, right? So we're pumping air through. A hydraulic system actually pumps liquid through. So a heavy construction machinery like this, it would actually pump liquid through the different tubes and cause the cylinders to expand and contract. And the advantage of having hydraulics is that because liquid is denser than air, it makes it so that you can perform a lot stronger tasks. It can make the piston expand and contract a lot stronger. And also it is a lot more responsive because there's less room for liquids to move around. And what that does is that it creates a machine that is a lot stronger and more capable of doing things like heavy lifting, or in this case, digging holes in the ground. Very good. And hydraulics is also how companies like Boston Dynamics can create robots that are really agile and very strong. So you can see here that this robot is able to perform these gymnastics moves because of a hydraulic system. You wouldn't normally be able to do something like this with gears or pulleys because gears and pulleys or levers, these are really great for rotational energy transfer. But when you need linear energy transfer, when you need things to be pushed and pulled, then hydraulics is the way to go. You can see here that there are a lot of cables running around this robot. So some of these thicker cables are for guiding wires through the robot. But some of the smaller ones, if you look at its legs, there's a hydraulic system. So those are where liquids are being pumped in and out of. Okay. Excellent. So now what we're going to do is we're going to have a look at some of the cool machines you can build with a pneumatic system with BricQ Motion Prime. So let's have another look over here on my screen. So this is the only model that the BricQ Motion Prime comes with to suggest using the pneumatic system for it. But it also has some other capabilities. So here I have designed a new model, and it is a scissor lift. So you can probably see in the on the screen that we have a scissor system over here, and the scissor system is actually part of some instruction in the booklet. But the pneumatic system is something that I added on top of it. So here, what it's supposed to do is you're supposed to be able to choose which part of the pneumatic cylinder to pump the air into. And then depending on if you're making the system contract or expand, it'll make the scissor lift go up and down. So I'll just put it over here and then demonstrate. So if I'm pumping air through, that's causing it to contract, but the other direction is going to make it expand. See? So let's do it again, and maybe I'll do a close-up view as well. You can see how this model is really, really cool. It's like got this really smooth motion that you wouldn't get if you were using like electronic parts, because the pneumatic system gives it a little bit of easing effect so that it makes it less robotic. It's really, really cool. I'll get a more closer view of the model. Whoops. Over here. My hand like around here so that I can. So this is making the model the piston expand, and when it expands the scissors, the model goes down. So I switch the valve to the other side, and then now when I am spinning the pump, the model will now contract and cause the scissors to lift itself up. Okay. Do it again. See? How cool is that? So you can think about using these pneumatic systems in a robotics context as well, because one of the difficulties when designing a robot is to do translational movement. Any kind of movement that you want to lift or lower something, or push or pull something, that is rather difficult using just gears, because you usually need to use something like a gear rack in order to do those linear movements. And when you do that, there's also an inefficiency in that kind of motion. So when you do use pneumatics, it tends to be a little bit more efficient, and it's also a little bit stronger as well. Okay. Black backflip robot is so epic. Yeah, that is pretty cool. Hey, that's the Boston Dynamics Atlas robot. Cool. Any questions so far? So we looked at a whole bunch of different things today. We looked at the original BricQ Motion Prime model, and we looked at how pneumatic systems work. And we also talked about how pneumatic systems differ from these traditional energy transfer mechanisms like gears and pulleys. We looked at a version of pneumatics called hydraulics, and how hydraulics can improve on pneumatics in being more responsive and more powerful in their action. And also, finally, we looked at some new models as well that you can build using the BricQ Motion Prime kit. I hope you enjoyed the video this week. Next week, we are going to do some more activities with BricQ Motion Prime. And if you have any suggestions, feel free to comment in the comment section below. Okay? I hope you enjoyed the video. I'll see you again next week. Bye-bye.